Hey guys, Mr. Brotherton here to kind of help you with some of the things I noticed. Um, in our review yesterday, a lot of people were asking very similar questions. First thing I want to talk about though is I hope you're following your social distancing rules so we can get this thing over with. I have my shirt on to help remind me that humans are gross and we all need to stay at home. All right. So the main thing I noticed was about question number 22 regarding electron transport chains that are happening in both the cellular respiration process and are happening in photosynthesis during the light reactions. So I drew up this little generic electron transport chain. So this applies to both the one that's in cellular respiration and the one that takes place in photosynthesis. So uh, the way I think about this, hopefully you'll find helpful or at least amusing. So I think about electrons as kind of the world's absolute worst babysitters. Okay, so if you imagine that you're a terrible, terrible babysitter and some irresponsible person decides, hey, I'd like that guy to watch 50 babies. All right, so instead of actually watching 50 babies, you just stick 50 babies all together in one tiny little playpen. What's going to happen with those babies? Well, they're probably going to freak out and want out of that playpen. All right, electrons kind of act exactly the same way. So if you look here, what this is showing you is this blob is kind of just a protein. All right, it's in a membrane. That's what these lines represent. This is a membrane. And then this thing right here, this is ATP synthase. ACE means enzyme. Okay, ATP is the thing that powers all cell processes. So this thing just puts together ATP. That's its job. Okay, so back to our electrons here. These little electrons, they have a negative charge. All right. And so what they do is all of these electrons, they attract these hydrogens that are positively charged. All right. And then what they do is they concentrate all of them into this little space. Okay, so just like our babysitter example, our electrons would be the babysitters. They grab all these hydrogens and then they stick them all together in here. All right, so now you have all these hydrogens that have the exact same charge, all stuck together, and they don't want to hang out with each other. Okay, positive charged things repel one another, they do not want to hang out together. So now imagine this in our playpen, maybe we decide to put a tiny little trap door in there. There's only one way out. All right. And let's say the smartest baby of the bunch is the first one who figures out how to get out there. All right. So if we go back to our electron transport chain here, that's what ATP synthase does. It kind of acts as a trap door. It's the only way out from all of these things stuck together. So what a hydrogen does is it's like, awesome, let me out of here. I finally found the way out. And it goes, shoots through this thing, ATP synthase. And ATP synthase kind of acts like a turbine or a mill wheel, and it spins around in a circle. And that spinning, all right, is what allows ATP to get put together. So that spinning motion actually powers sticking ADP plus P to make ATP. So now we're back in here, we're back in our membrane, and these little hydrogens are kind of happy because there's not too many of them all stuck together. What they don't know is this probably going to happen to them again, and they're going to end up back over here. So the question was, what actually powers ATP synthase or ATP synthesis? It is hydrogen ions. So positively charged hydrogen being attracted to electrons. They all get concentrated in one place. And then once they're all concentrated, they want out. And because they want out, they go back through ATP synthase. And that spinning motion sticks ATP, okay, or it sticks ADP plus a P together to make ATP. And that is how all life on Earth powers itself. Hopefully that was helpful for you guys. Remember, stay at home.